All right, so welcome to our programming language. Today will be, I would say, a little bit of recap in SQL. We'll talk about relational databases, the history behind them, behind the basic ideas, actually why we need some sort of database, of course, and also why relational database, the approach, why it won over some other approach. And of course, we will see also shortly, also some other approaches do exist, of course, NoSQL in general, right? So again, it's, I would say, even though the subject in the basic ideas are very easy, I would say they are also quite important because it's useful pretty much everywhere, right? It's the one language from this course you can learn and use it, apply in pretty much any project, basically. And it's still relevant 45, 50 years later, basically. You know, I guess C would be equally influential. I guess in terms of influence, C would be more important, but C is not as widely used these days. I mean, besides Linux kernel, for example, but not too many projects use pure C, right? But SQL is used as a persistence layer in some form pretty much everywhere, right? You name a project, you know, it exists somewhere. Of course, even your browsers, persistence in your browsers usually is handled by SQLite. Some state, some configuration is used everywhere. Use SQLite, which of course is a form of SQL. So that's a big picture, right? And let's have a little overview of the history behind this, right? Again, I understand you took some, you had some SQL in the Harvard course, I believe, a little bit, right? Yes. Anywhere else? No, not everywhere. Just the Harvard course had some. Right, and you were doing little CRUD work, right, which is most of the work anyways, right? So what did we do? Oh, well, actually, that's a notebook. I want to open the. Where's my code space? What happened with my code? Oh, I didn't open it up. I guess I should open it up. All right, Turbo Palm 3. Thought I opened it up already. Right. So we can actually add some code as well. All right, so SQL is a programming language. It's a real programming language, just like any other language. But of course, it is domain specific, right? It is meant for manipulating data stored in relational databases, right? So theoretically, you could use it for anything else. I mean, you could write Tetris in it, and you can write a game, and it's Turing complete. But it's sort of say its strength, right? That's why it's called domain-specific language, right? The domain for a specific domain. In this case, it's the manipulation of data in relational databases. Again, so create, read, update, delete. Also, it has some analytics functions, some aggregation functions, right? So, what's interesting is this is it's a declarative language. So there are some parallels with Prolog in the day that we define knowledge, right? And then we do something with this knowledge, right? So it's a big abstraction. How this knowledge is stored as users of SQL, typical SQL users will not be aware of exactly the mechanics how the data is stored, right? You have no, of course, relations to do some work, but the actual deep level knowledge is not necessary, right? So, why this is important? Because it allowed for SQL to remain relevant. The actual engines, the database engines, have advanced tremendously since 1970s when the SQL was introduced. But the core basic language has stayed roughly the same. Of course, some additional features have come, but the general idea how you work with this relational database has stayed the same. So very powerful. So we got in all these improvements from an engine, right? But we don't have to learn new skills, right? Basically, oh, there. So. Right. It is again, so the target audience, original target audience was actually not just programmers. It was meant to be for business analysts, right? Business owners, managers, anybody working with data, basically, right? So that's the core audience, the original audience, right? So again, so that's why the syntax was considered relatively simple, right? Again, because you want to acquire data. So let's see if I go into history. Yes, there's a little bit of history also, right? So, we have all kinds of data, right? We have, natural, transport, geographical, cultural, you name it, right? So, and of course, pretty much, why do we need databases, right? That's the question, right? Why can't you store everything in text files, right? Why can't you store everything in the memory, right? Why do you need something specific, right? Why do you need specific language? So originally, of course, data was mostly stored in terms of punch cards, right? So you see, so how many bytes can you store in this card, right? Let's see. So we have each punch is 1 bit, basically, right? Let me open this in new, can I open this in a new cell? All right, so you can see this, right? So this is a punch card from, I don't know, mid-50s, mid-60s, still around up to 1980s, but of course introduced in even before computers in the late 19th century, right? So this is how you store data, basically, right? So I believe there's 40 bytes here, right? Why did I say 40 bytes? Because each, you could think of this is each bit, right? So each punch or lack of punch is 1 bit, right? And you have 40, I believe there's 40 columns. I believe 40 columns. And there's some error checking going on here as well, maybe some metadata possibly, right? So, and again, but of course you have a whole bunch of stack of cards. How do you access this information, right? It's quite painful. I mean, but you could, of course, build these special sorters which look for specific bits, right? There's special mechanical devices which look for specific bits. It's like one bit says, okay, male, female bit, right? You could look for that bit, for example, or age bit, like certain age categories, you could look for those bits, for example, just an example, right? But of course, more complicated queries, you need to basically build custom hardware, right? And also sometimes as your need for extra queries grew, right? Of course, you couldn't really, there were things you couldn't do, basically, right? So, but originally, when we transferred 1950s started to transfer this punch card, right? The analogy held, basically the abstraction of how original data was stored was also kind of like physical data, meaning you store them on a tape or for early hard drives. You still store them in sort of this fixed format, right? So this is the thing. So 1960s, they were very simple. Actually, this here, I don't know, yeah, so there's going to be a little history, hopefully before code, right? So let's talk about a little bit before code, right? Before code, right, there were some ideas. Let me add some links here. Let's see here. I want to enable completions. Open menu, enable completions. So, right, first base, right, there were some competing technology, like hierarchical database, network database, traditional one, right? So it basically revolutionized this whole database space, right? In fact, you'll see some of these other ideas like hierarchical databases, right? Network databases, sort of like graph databases, then they're kind of coming back a little bit in today's world. As under the guise of NoSQL, right? But SQL is the dominant one. So this guy here, Edgar F. Codd, British computer scientist, 1969, 1970s, early 70s, paper Relational model for data. So what's the basic idea is that we do what? How do we store data? In what format? As tables, of course, as tables, like, which is of course easy to understand for humans, an important point, right? So we don't build these nasty, very complicated graphs. Instead, we won't escape the graphs completely, but because we'll need to do it for relations. But the actual data is stored as tables, and the key insight was, of course, that you don't want to duplicate the data, right? You do something called normalization, right? Your data is normalized, right? And so on each table can be linked to multiple other tables by the use of so-called foreign keys. You have primary keys, foreign keys, right? So on this can be used, this sort of like underneath there's a set algebra, again, which most normal people don't want to learn, but again, that's what underlies the actual this growth. So the basic idea is this, right? So we have, okay, maybe let's look at this example, right? So we have employee table, we have department table, right? And we can map the relations, right? We can, for example, add, for example, when employee joined the department, right? So these little numbers, we should look at this table, this middle table. It looks really, really kind of, I don't want to say boring, but just very technical, just some numbers, right? But you can link, okay, so employee 1, right? His name is, I don't know, Egils or Emils maybe, I don't know, right? Or employee 1, right? And he lives at, I don't know, Avotuil, right? So he joined this department 1, again, so I don't know, accounting, let's call it accounting, right? So accounting B, right? So it's very simple, a kind of boring example, right? And location, I don't know where, right? I don't know, A would be, I don't know, Adaji, I don't know, right? B would be Babita, I don't know, right? So, and you can link this information, so you only need this ID, right? So each particular piece of information can actually stay in one particular table, and you can link them together, basically, right? So you don't duplicate. Your only duplication you do with these IDs, basically. These IDs link everything together, and then using, of course, SQL, right? You can retrieve this information. And this seemingly a little bit sort of like, I don't know, kind of seems like, why couldn't you just put everything in one table? Yes, you can. Of course, you can. It's not prohibited, actually, right? But you can actually generate these tables, right? But actually underneath, you store them as the relations. So, right. So actually, how did it come? So Code's paper was influential. So early, I believe it was actually Boyce, actually, and Chamberlain actually released this, designed this language, right? Because Code introduced the idea of these relational databases, right? But actual language, well, was left up for research. And then, of course, there's this little known guy, Larry Ellison, right? Who I think he worked for Kellogg. I believe for Kellogg. He was making, I think, cornflakes or something like that, marketing, right? He was not pure he was not pure programmer, right? I think Kellogg, right? Larry Ellison, right? He's only like what third richest guy in the world right now, right? Or something like that, right? And he's been like that for forever, right? Probably gonna live forever, right? If you've seen him, what he looks like these days, he probably drinks blood, right? Of us, basically, right? And I mean, of you probably, not me. I'm too old, right? So no, okay, that's a side quest, right? But yeah, he basically, then he was probably, I don't know, 30 years, something like that, years old. He realized this is a big idea, right? So, and he found Oracle, right? Which you see, we have we have one of our regional headquarters here in Riga, right? So, to maybe some people actually work for them, actually, right? So, hey, but basically, it on a strength of relational database and SQL, its particular version of Oracle SQL, right? It became one of the biggest corporations in the world, actually, right? So. Now there's a standard, so you don't have to use Oracle. So that's the beauty, of course, is right. If you don't like Oracle, right? It's expensive, right? You don't have to use it, right? There's many alternatives. In fact, we will see that despite the SQLite, which is completely free, open source, everything, I think public domain actually, right? It's the most popular SQL database in the world. I think multiple billions of installations, right? Because every Android device comes with it, right? I think even iPhone has it also underneath. Every Python comes with it, actually, right? It's embedded everywhere, basically, right? So it is, again, why do we need it, right? Because we need to store some data, persistence, when our computers are off, right? We can't keep your computers running all the time, right? Maybe we have data as a persistence, but actual queries to retrieve this data might come later. We don't know when, right? We actually have some knowledge, right? So, which we want to store, but we don't know when we're going to retrieve it, right? But we want to retrieve it, right? We want to have this possibility of retrieving it at some point, hopefully sometime in the future. In fact, like I said, I already mentioned there are quite a bit of competition, right? NoSQL, there's actually roughly four types of different NoSQL databases. So if you hear somebody saying NoSQL, it is not just one thing. There's something called document databases. MongoDB. Who has used MongoDB here? Anyone? Couple, right? One. Right. So if you like JSON, then MongoDB, this binary JSON would be probably your option, right? Again, for a while, for about 10 years ago, people thought, okay, maybe MongoDB is going to be the next amazing thing, right? So if you see this, okay, yeah. So if you look at the let's look at the rankings here. Let's look at the rankings. What's happening actually today, right? So database Oracle, right? It's a leader, still a leader. What's amazing to me, actually, I don't know why is MySQL actually so high up, right? Why? Because, by the way, who do you think owns MySQL? Do you know? Any idea? No, because number 3 is Microsoft SQL Server, right? It's a little bit of a question. Do you know the story? Because I'm a little surprised again. Why? Because let's take a look again. I don't want to like now be offhand, but I have this bet. If I remember my history, okay, MySQL also was bought by Oracle. I believe so, because really what people are using MySQL, of course, was the free and open source one, right? And now it's MariaDB. MariaDB is actually what everybody's using, right? If you're starting a new project, you want to use MySQL, you're actually using MariaDB, actually, right? Because that's it. So what happens? The beauty of open source projects is, of course, if you don't like the new owner, you can fork it yourself and start a new project, basically, right? So that's what happened, actually, right? With MySQL, right? So I believe so, right? Because MySQL was under Sun, yeah. Oracle bought Sun, right? There used to be a very important computer company called Sun, and by visiting it got MySQL. So people, of course, were yes.
Why would you ever buy it if it's free and open source?
Exactly, that's a good question. But then why would you buy GitHub, for example, for $8 billion, right? If it's really just some bunch of projects, right? And you don't really gain anything. Market share? No, it's basically Sun was kind of okay. Sun was doing this when Sun was important, making servers, very cool company actually, right, with some cool ideas, right, very influential. But they had some money at the time, right, early, like it was around, when did they buy MySQL, right? So when you buy something like this, what do you get? You get mind share, right? You get users, theoretically speaking, right? Because there's inertia, and that's exactly what's happened actually. People still apparently use MySQL, even though there's not really much good reason to use MySQL, because why? It's owned by Oracle, who has their own commercial product. So MySQL development depends on open source contributors mostly, right? And some whatever, maybe some nudging, some sort of hints from Oracle, maybe, maybe some slight funding, right? So that's the thing. So what usually happens, of course, there is MariaDB, right, which is actually where everybody who was using MySQL, developers actually who improve it, are using that actually, right? But it's funny that MySQL is still number 2. So that's really interesting, this, right? Because why are so many people using MySQL? Because this purchase, right? If you check history, right? It was started, I think, 90s, right? Yeah, 1990s, 29 years ago, almost 30 years. This year they'll have 30-year anniversary, right? So this was early 2000s. MySQL drove the second internet, boom or revolution, if you want to call it, using LAMP stack, right? You run Linux, Apache, right? MySQL, and you run Perl, PHP, or Python. So you call it the famous LAMP stack, right? So M stands for MySQL, right? Now it's supposed to stand for MariaDB, right? And of course, after that we have different other stacks, right? There's WAMP stack, that's Windows. If you want to run Windows, you could run Windows, right? So there are other versions. So apparently, well, even Facebook is, I don't know, Flickr, MediaWiki, Twitter, YouTube, possibly. I'm a bit surprised. I guess there's a big thing in inertia, right? Again, if it's not broken, right? But let's see this history, right? So these two Swedish guys, right? And it was bought for, I think, $1 billion, right? They bought for $1 million. Yeah. 2008, right? Yeah, $1 billion. So open source, right? I mean, at the time, you could buy this, you could clone it, fork it, the license allows you can make your own version. Again, some people did. Because when Sun acquired this for $1 billion, Sun had a good reputation, right? So this was seen as a good thing. Everybody still continues using MySQL. The problem was, right, the day Oracle announced the purchase of Sun, Michael Montevidenius forked MySQL. And Videnius, I think, is one of the original developers, I believe, right? Yes. So the original guy who sold it for $1 billion, of course, he didn't get the $1 billion, right? He was just one of the open source guys, founders, right? So he forked it, right? Which, and he had better reputation than Oracle, right? So that's what happens, of course. And that's actually, I think that's great, actually, right? You need some competition, right? So Yeah, so this is of course a side quest because MySQL is still very important, but it's of course not the only version. But what I want to show you here is that look at the count how many relational database models are in DB engines, and especially SQL, Oracle. So SQL, 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 right? First, top 4 is SQL. Then you have IBM DB. I believe it's not quite SQL, I believe, but there's something on SQLite, right? That's 5 out of 10, right? No SQL, MongoDB, Snowflake, kind of. Redis, of course, is very important in caching, right? Key value store, right? It's a NoSQL database, technically, right? Cassandra, right? Access is not really SQL, I believe, but it's of course it's relational. So MariaDB, right? And there's other SQL versions. So basically, SQL is like the main way of accessing information, right? So, yeah, so that's it's popular, right? Now, right, so we go to where's my history? Where's my notebook? There? Oh no, that's not it. Where's my notebook? Okay. Oh, there's a GitHub. Where's my? Can't I? I think here. No. Where's my? Oh, engine ranking. Okay, yeah, engine ranking. Okay, so competition. So Oracle. Yeah. So this was last time I checked, but maybe this has been changed a little bit. No, but it's still roughly the same. So the core idea. Let's go back to the core idea is to organize your data in tables. So rows and columns. Each row represents so-called individual record or data item. And of course, column represents specific type of data. So in columns, you specify what type of data it is going to be. Integers, strings, and there are lots of different types, of course, right? But the idea is to normalize. So we break down our data into smallest possible parts and organize those parts in these tables, basically, right? So it turns out, work or interview. Yeah. Oh, good luck.
Hopefully.
Yeah, break a leg, right? Or yeah. Right. So talk about SQL. Right. You know SQL, right? So, and because why do it? When I talk about again, they will see this why you should learn SQL, because it turns out lots of people don't want to learn SQL at all. So instead they learn some library for managing SQL, so-called ORMs, right? Which is good to know, but there's so many of them, and you can't learn all different ORMs, but you can learn SQL to a good level actually, right? So this power of relational database is to how we establish these relationships, right? So we can combine, analyze, right? So again, example could be you have one table of customer information, another table for order information, third table for product information. So then we can, analyze customer behavior, track inventory, of course, right? Identify trends, right? So it's flexible, it's very scalable. Again, SQL database is pretty much can run as much data as you want, right? Even the smallest SQLite, you can go up to 100. Last time I checked, it was 140 terabytes, right? For SQLite, which is considered light database, right? So again. So this conceptual model, right? So this, of course, is theory, right? So entity relationship model. So idea is you can model your data, right? So entities which represent these objects, right? And there are going to be some properties. So you can say, okay, so this account has character, right? There's a character. So this will be a game. You're making a game, right? This is the example how you would make a game. Let me see if I can give you a link here. I'll open up in a new. Come on, open a new. Come on, I'll copy this. I'll open, this here. Yeah, right. So this is a little game version, right? You're making a game for. You have creep, which of course is some sort of enemy, right? You have character. You have regions where you are, it's multi-room or multi-land game, right? And you have weapons, right? Of course, items, right? So obviously. You can model a lot of properties like this, and pretty much unlimited, right? So what's interesting, of course, is us on the need to know, as your needs grow, some of these things can acquire, instead of being entities, they can actually become, some of the properties can become their own entities sometimes, right? So here, of course, you have account, right? Of course, what account needs password, last signed on, right? Address, email, and so on, right? You could For example, address could become its own entity, for example, right? Because address could be more detailed, like maybe you need information here actually, right? Maybe the email, phone, address, could go separately actually. It's possible, right? Again, there are all things you can model like this. But basically, it's unlimited modeling. So notice something here, mn1n, right? So idea being that the character, I mean, if you have some weapon, right? A particular character can have this weapon. You can have multiple weapons, multiple items, right? Of course, right? But no, you cannot share in this particular model, in this particular game version, right? You are not allowed to share this weapon. If if you drop your weapon, somebody else can pick it up. But in a database, each, so n to n, one to many relationship. So one character can have multiple items, which only makes sense, right? But particular item is only related to some particular character, right? However, creep, meaning creep is NPC basically, non-player character, right? Or a bad, evil NPC, right? Creep, right? I'll call it NPC, right? This is PC and NPC, right? M and N, many, right? So because multiple monsters can meet multiple characters, right? There could be multiple characters. This is a multiplayer game, right? MMORPG, a massive multiplayer online role-playing game, right? I'm sure some of you have played some MMORPGs, right? So, and of course also you have regions, right? So n to 1. So again, in this case, right? Of course, a player can be only in this particular region, right? However, right, a region can contain multiple players, because it's MMO, it's in a name, massive multiplayer, right? So it'd be kind of stupid to make an MMORPG, but with only single, each room has only, solo players only, it's kind of lose its meaning, you might make a first player RPG only, right? So on. So yeah, so these little things are important. So these are used for modeling. Obviously, these requirements might change, right? Maybe you decide that items could be shared, then you might not, maybe instead of one, you have M here, basically, right? So these are important when you're creating your application or looking at something else, right? So this basic idea of these entities and their relationships, right? So entities, right? And of course, you have some, so here also, account, right? Each character is owned by a particular account, but your account, your player account is allowed to have multiple characters, right? You can play multiple, right? You can, again, it's not here in this particular model, it's not explained whether you need to log out, can you play multiple characters at the same time? Probably not, right? It's not, that's not, this database, this entity relationship diagram is not detailed enough for that. But again, it's very powerful, right? How you can model, and this, again, the beauty of this relationship, of this relational databases, that you can model pretty much anything, right? Sometimes it doesn't work that well, right? But for most day-to-day tasks, this modeling works quite well, like as in this example. So, right, so again, another example, right? So I was talking about these relationships, right? So we have one-to-one and one-to-many, right? So one-to-one, so each record, right, only one table, basically. So it's one-to-one, one-to-many, right? So it's possible artist performs one song, maybe this artist has never performed a song, I mean, it's possible, right? So there's different type of, like in this example, right, we saw this sort of like, there are no crow's feet. Oftentimes you use so-called crow's feet, right? So artist performs, right, on a song, right? Yeah, you've seen this one, right? I'm sure you've seen it, right? So there are other notations. This is one of the most common, right? So many to one, right? So meaning inverse, right? This means, right, so many orders can be, again, we assume that a purchaser, a customer, right, is allowed to buy many times, but a particular purchase, this order, is actually, only one guy, right, or one girl, right? So, also, many customers, right, can be associated with many products, right, through their orders, meaning not particular purchase, but you can say, okay, this customer likes, I don't know, this type of breakfast cereal, right? They buy this, and of course, other customers may also like this breakfast cereal, and maybe some other ones like this other cereal, right? So we will see we'll have some exercises with a song or music database. It's pretty popular for learning. So standards, yes, there are some standards. What does it mean is, of course, that all the commercial and non-commercial free open source the SQL database, there's the underlying language, right? The basics stay the same, right? So they're actually up to 2016. Yes, yeah, if you want, for some reason, I don't know why would you want to do this, you can buy the actual standard. Last I checked, it's only, oh, it's actually outdated now, there's a new one, 23. Oh yes, this is a new version. It's only, how much does it cost? Shipping cost not included. I want the PDF, I want paper. Why? Add to cart. It's zero now, it's free. I don't believe it. It used to be like, 300 Swiss francs or something like that. Right? Let me add to cart. Continue shopping. Maybe it's now free. I like that. I don't know. Maybe they decide like it's kind of stupid to ask for money because ISO, right? ISO is a standards organization. Of course, you don't really need to do it. It's open the source, right? Maybe they decide to do the right thing, actually give it for free. I don't know why. But yes, let me add this to new standard, right? And there's actually 2023 version. Let me add this, update the update the version. It's kind of cool, right? Yeah, new version, update. Now 23 version. Yeah. Okay, so we'll look at some syntax in a moment. Right? So basic syntax, which again most of you know already somehow remember, right? So you have this 4 major operations: reading, creating, reading, updating, and deleting data, right? So again, it is sort of like all caps, but then we'll see this language actually. It's not actually. Why does SQL still use all caps? Sort of this syntax, right? It's from 1970s. Where actually many keyboards and many displays only had one type of case, only uppercase or lowercase, right? So that's kind of remains from that day, right? So you'll need to learn some syntax. We'll do that after the break. We'll do some syntax, and also to do any useful work, you need, of course, realize the schema of your database, right? To actually know how these tables are related to each other. So today we will look at the SQLite, not only it's called a Chinook database, which is basically, I think mostly fake data, about some it looks like iTunes purchase list from like mid-2000s, right? With some customers, some invoices. So this is what you usually start. Usually you'll be using some sort of database IDE, which supports this viewing of these tables, right? There's plugins for Visual Studio Code these days, but also there's separate engines, separate applications such as DBeaver or commercial applications from, let's say, Oracle or Microsoft, right, which let you see these tables because you want to see these tables. So let's take this, oh, come on, where's my schema? Yeah, so let's look at this here, right? So let's look at this schema in a moment, right? And we will explore this schema. Right, so let me make this bigger, right? So we see how many tables are here. 1, 2, 11 tables, right? And notice again, of course, it would not be a relational database, a real relational database without relations, right? So these tables are related to each other in some way, right? Some tables also, interesting to know that some tables are related to themselves. Why is that, for example? Employees. Why is there employees have relation here, right? Why? Because this lets you have if you have an employee who is actually, there's a manager, right, and there's an employee who is under them, reporting to them, right, it lets you actually model some sort of hierarchical relationship, actually, right? So we have employees, we have customers, and what's interesting here, you notice invoices, right? But invoices, actually, there's also invoice items, right? The cost, right? So it's a little bit not as simple as you would think, actually. So tracks, usually you purchase tracks. So tracks is something that goes on invoice items, but they don't go directly on invoices, right? It's because again, this lets you be more flexible. Similarly, if you are creating a playlist, right? Playlist of your favorite tracks, you don't actually, notice you don't actually, you have a name, You have a playlist, whole bunch of playlists, and then you have tracks. On each track, basically, this lists the playlist, meaning it's actual name of the. This is relatively short table. It's like, oh, my Sunday favorites, my party list, and so on. A very small table, but the actual information stays here, and it is purely numerical relations between which track ID goes to which playlist ID, right? So, let's say my track 1 goes to playlist 1, right? Which actually means playlist 1 stands for my party list, right? And track 1 is to, I don't know, ABBA Dancing Queen or something like that, right? So, and the tracks actually go here, right? So we'll look at this in more in detail in a moment, right? But again, so there are some tables which actually have a lot of information, right? And some are which purely just for relations. And again, and why is this done so? Because it's because of this process of normalization, right? And again, it's a special category. It's a very, again, being a database administrator, building databases is actually quite challenging, right? Of course, these days usually it's not a standalone. It's something part of a bigger, system application of system designer, right? System architect and so on job, right? Like building something. So you have to learn. Maybe if you're doing a startup, of course, you'll have to do it yourself, right? So. So it's not so bad, right? Of course I will show you some really huge tables, right? This is not a big database, right? Maybe before the break I'll show you some big SQL table examples, right? Maybe no. Like these I don't see any nice nasty pictures, right? I was showing something what would do really. I've seen some Latvian ones like. Latvian databases which are very big, right? So there's two things. It's actually number of data. I mean, you have a single table, right? It's technically SQL if it's just a single table with many entries, billions of rows. That's possible too. Large SQL schema examples, right? I want to show you something big, basically. Oh yeah. So this is like medium sized, right? Yeah. Right. Medium size. So this is what happens, right? If you go a little bit crazy, right? And I like it's nicely shaded, basically, right? You don't have to worry about the actual what's inside there. But yeah, it's possible you have something like this. And again, it's possible to make sense of it, actually, right? Because of these relations. So this is of course relatively, I would say above average, right? So yeah. So naming, again, just like with variables in regular programming, is extremely important. So this is something you hopefully won't have to see this. Not as big, but yeah, but it's manageable. Again, it's not to be, maybe you wouldn't build it yourself these days. You'd use some analysis tools, some LLMs to help you actually to make sense of it. There's, of course, tools to help you, right? So let's take a break. Let's continue in 10 minutes at 2:55. Okay? Yeah.